So Brian Meeker. Brian is a coworker of mine. Brian is a remote software engineer who occasionally leaves his basement in Indiana. I know that for a fact because he just went outside for some fresh air because he is working on a project trying to defend democracy. And so he's a recovering Perl monger. He loves writing applications across a variety of technologies and platforms. He gets to indulge this as a consultant at our company, InfernoRed Technology, where we both work. He's also the founder of a now defunct Richmond Tech meetup, where he learned how difficult it is to organize a monthly meetup in an area with a very small tech community. Well, now there's no excuse. It can be virtual and it can go big. And outside of work, Brian is a devoted father, avid Magic the Gathering player, and lover of metal. So with that, Brian, go ahead and you can share your content now, and I will queue that up, and I will send it live.
Thanks, Scott. Well, the bad news is that it just asked me for permissions to share my screen after it did not do that before. So this might take a minute to get this straightened out.
That's okay. We can wait to do that as you're sorting out your sharing. Should be just a second. All right, I see your desktop, and I am going to push that live with your live video stream, and you are live. So there is a 20-second or so delay. Just keep that in mind as you guys ask questions, or Brian, if you ask questions. And would you rather answer questions that are in line or at the end?
I think at the end would be preferred.
Okay, so as they come in, we'll hold the questions. If you have any, please post them in the Q&A. If not, no problem, and we will talk to you in the Discord channel. So with that, Brian, take it away.
Thanks, Scott. Thanks everybody for attending. Thanks for sticking around for the last talk of the day. This is not a technical talk, so I encourage you to sit back and relax a little bit. My goal is to cover over 50 years of version control history in about 45 minutes. So we have a lot to get through, so let's dive right in. Like Scott said, my name is Brian Meeker. I work remotely as a consultant at InfernoRed from Richmond, Indiana. And he already read my bio, so we won't go through all that. So what is version control? I'm not above stooping to Wikipedia for definitions. This one is pretty straightforward and probably matches your intuition about what version control is. But I like this version from the official Git book more. I like that it calls out recalling specific versions later. You notice that this definition doesn't lay out any specific requirements about what features a version control system needs to have. You just need to record changes so you can get back to a specific version if needed. That's it. There are a couple of different terms for version control. I'm going to try and be consistent here and use the term version control system, but these are mostly interchangeable. These topics are interesting, but they're going to be out of scope for today. We're not going to talk about any hosting services. Integrated version control is things like built into modern word processors, spreadsheets, or CMSs. We're not going to talk about wikis, and we're not going to talk about most commercial systems with one very important exception. So when I originally came up with the idea for this talk, I put punch cards in the title because from punch cards to get sounds really snappy, but then I had to figure out what the punch card part of that even meant. I've been a programmer for a long time now, but I'm not old enough to have used punch cards, and that's probably true of just about everybody in the audience. So these are punch cards. So let's imagine that it's around 1964 and that you've just received your new assignment. You've looked over the requirements, you've written out your code by hand, and now you need to get your code ready. There's no concept of version control here as we understand it, but what we can do is talk about how a programmer would maintain his punch card deck, just with the understanding that it's not version control. This is a key punch machine. After writing your program on coding sheets, you would take your sheets over to a key punch operator. This operator would use the machine to turn your written source code into something that could be fed into a computer. This model specifically is an IBM 029 key punch. It was introduced in 1964 at the same time as the IBM 360. So now you have your punch cards, but could a computer directly run these punch cards? If you look closely at the top of the card here, you'll see source code. And punch cards from the key punch machine are just your source code in a format that can be fed into the computer. And so just like we do today with what you do with source code before the machine actually runs it, we compile it. Sometimes that's implicit, sometimes it's explicit. With punch cards, you end up with this. This is a compiled punch card that after you take it to the computer operator. This particular compiled card contains a self-loading IBM 1130 program that would copy the deck of cards placed after it in the input hopper. So if you are incredibly lucky, good, and or fortunate to have a simple task, then your program would compile for the first time. Let's assume you're great and that it did compile correctly. So next, the computer operator would load your deck of compiled punch cards into the machine to execute the program. You would then get back your original deck, your compiled deck, and your printed output. Chances are good that your program didn't work correctly the first time, though. It almost never does, and you have to remember that these programmers had no real-time feedback. They didn't have a test suite running constantly. There's no debugger, there's no IDE, they don't have any of that. So now we could finally get to the real problem. How did the programmer manage changes to their punch card deck? First, your helpful key punch operator would often draw a diagonal line like this across the top of your cards. Now, if you dropped your deck, you could put it back in order just by recreating that line. It's not a robust system, but the opportunity cost of drawing a red line is extremely low. But what would happen if you start making edits to your deck? The key punch operator shouldn't have to type up a new copy of your deck every time you make a change. As a programmer, you should be able to type up a new card as needed to insert into your deck. However, your line's going to fall apart pretty quickly and just become a jagged mess. One common solution for this was sequence numbers. A standard punch card has 80 columns. And if you look closely at this card, you'll see the columns labeled at the top and the bottom all the way to 80. However, it was common practice for compilers to only look at the first 72 columns on the card. So that gives you 8 unused columns, and those could be used to order the deck. I didn't spend the time to get good at reading these cards, but this is another Fortran card with the sequence number PUX 430 on it. So with those, you could take them to a card sorting machine like this. This is an IBM 082 at the Living Computer Museum in Seattle. This particular model came out in 1949 and could sort 650 cards per minute. So if your deck got out of order, you could use a machine like this to sort it by sequence number. That kind of just shifts the problem around, though. So what if we have our sorted deck and we want to insert a new card in the middle of our program? How do we easily renumber our cards? We're programmers, so we do what we always do. We write a program for it. You feed your deck into the machine in the new order. The machine ignores the existing sequence numbers and copies your deck with new sequence numbers. There's still a lot of limitations here. Getting new sequence numbers is automated, but if you put a card in the wrong spot in the deck, you won't have any record of that. Depending on the mistake, you might not realize anything is wrong until your program executes. There's also no trail of any changes, and collaborating with any other programmers is very difficult. You have to carefully negotiate who is working on what. And even when working by yourself, you can't look at your history and figure out where you introduced a bug. So for a while while putting together this talk, I thought that sequence numbers and punch card sorters were the end of the line for the punch card era. And that was true for the vast majority of programmers. However, progress is not evenly distributed. I stumbled upon the proceedings from a Large Hadron Collider workshop in October of 1990. If you were a researcher at CERN in 1965, there was something else you could have used. And if you were still a CERN researcher in 1990, you still might be using the same system because progress is not evenly distributed. These proceedings contain a summary of code management systems being used by CERN researchers. The first system they mentioned is the one that interests us. It's called Apache, and at the time was the most widely used code manager in the high energy physics community. Apache is not a version control system, but it's an interesting advancement from punch cards. The source code would be loaded onto tape, but then correction cards could be fed into the machine to update the program on tape. History could be maintained then if all changes were made via these correction decks. Its primary strength within CERN was for distributing code to other sites on tape. Correction decks could also be circulated to update existing tapes, but that was considered less reliable. Apache is still used today to some extent. I'm not sure how much. There were release notes for it as late as October of 2016. If you want to play around with punch cards yourself, I highly recommend the virtual key punch. Things clicked a lot better for me once I could sit there and virtually type on the keyboard. But as far as I could tell, this is as far as the punch card world got. We're about to enter the world of multi-user operating systems and teletypes, and pretty soon punch cards would begin to fade out and source code would live on the computer itself, which meant it was time to start looking into software to manage it. As we go through history, we're going to refer to this table to reorient ourselves. The history of version control can be broken down into 3 generations based on certain features. The first generation is defined by no networking, only versioning one file at a time, and locks. Like most ideas, there are a lot of precursors that had some elements of version control, but it's widely agreed that SCCS, source code control system, is the first true version control system. The systems that existed before SCCS were mostly just about deltas of changes, and those are valuable, but they don't make a version control system. One of these precursors, though, was IBM's Clear, which tried to assist with the administration and accomplishment of the program development lifecycle. The only information I could find about Clear was from a software engineering techniques conference sponsored by the NATO Science Committee in 1969. And one part of Clear used deltas to help with versioning releases. This was actually the second of 2 NATO software engineering conferences, and the term software engineering was not in general use yet. They purposely chose the term to try to give the industry legitimacy. So back to SCCS, and is anybody surprised to see a Bell Labs logo? So the year is 1972. Mark Rochkind is working at Bell Labs, and he's struggling to deal with change management. He would summarize his work in his 1975 paper, The Source Code Control System. In it, he describes the 4 problems he was trying to solve. He's trying to save space, manage versions, track who changed things and when, and knowing what version the customer has. It's important to remember that memory was extremely precious at the time, so the size of files on disk was extremely important. And the distribution of releases was also difficult. There was no internet. Computers were still only owned by large organizations. So if you were distributing software, it was almost certainly an enterprise model, and customizations for the customer were common. Dealing with all these different versions for different customers was a challenge. So this was the tech stack for the initial prototype, which is a lot of stuff that means nothing today. They felt that the concept of version control was just too out there to win people over with the specification, so they prioritized ease of development. Snowball 4 was chosen because of its expressive power and ease of use. For its day, it was an incredibly powerful language. One person was able to write the initial prototype in just 3 months. Depending on the domain you work in, that might seem fast or slow, but you have to remember that this is 1972. In 2020, we stand on the shoulders of giants, and in 1972, that's quite a few shoulders below us. The downside of Snowball 4 and Spitball was size and speed, but that wasn't an issue during their 6-month trial run. The prototype was very successful, and several large applications were using it internally. In the fall of '73, there were several more projects interested in using SCCS, and the decision was made to write a whole new version. The interested projects were on multiple OSs, though, and the existing version only supported OS 360 still. So instead of writing different versions for each OS, which was still standard operating procedure then, they decided to write just one version that would run on a PDP-1145 under Unix. Source code would be stored on the PDP-11 and sent to the appropriate machine for compilation. And given the future dominance of Unix, this turned out to be a pretty wise decision. This is a picture of a PDP-1170, which is just an upgraded version of a PDP-1145. So that's all well and good, but how did it work? If you remember the features from the first generation, you remember that it only works on a single file at a time, and that file gets locked when you check it out, and there's no networking. Working on a single file at a time probably feel a bit alien to just about everybody. Each file was just treated as a separate module that was versioned independently. Release management's interesting, though. It's different from what we do today, so we'll dive into that a little bit. Once again, these figures are from Rochkind's original 1975 paper. I mentioned that the managing of versioning was a very big problem that SCCS hoped to tackle, and it did this through the concept of releases and levels. Each commit would increment the level of a release. So for example, if you create a file, it's at release 1, level 1, or 1.1. Committing a delta would increment the level to 1.2. So now we're at level 2.2, so now we're at 1.2. The release number would only increment if you explicitly started a new release with a command. So you have a lot of power over managing these releases. If you needed to make a fix to release 1, but release 2 is the most recent, you could check out the older release, make the change, and it wouldn't apply to release 2. But if you look at this, this looks really weird. There's no concept of branching. So you kind of just have to implicitly know that 1.5 in the bottom diagram is not actually part of release 2 unless you explicitly add it as well. They went back and forth on different behaviors before eventually landing on this one. So it's 2020 and we have mastered informative and conscientious commit messages, right? I assume that none of you work on teams that commonly use commit messages like this. Even in 1975, developers couldn't write commit messages. We're not going to talk about too many implementation details today, but I do want to talk about how SCCS stores data because it's different than any other system that we're going to talk about. The core of SCCS is something called interleaved deltas, and in his paper, Rochkind describes the problem he was trying to solve. He wanted something that was both space and processing efficient, and interleaved deltas satisfied both requirements. The space required to store the delta is only slightly greater than the amount of text inserted by the delta, and access speed was mostly flat. Any level could be reached in equal time. So all changes are stored with just 2 primitives. Lines are either being inserted or deleted. You can see on the initial commit some control records and text records. I stands for insert, E stands for end, and the rest of the highlighted records are just initial text. And then you can see the changes highlighted at 1.2, and here D stands for delete. You can see that some text from 1.1 was deleted and some new text was inserted. So how did he come up with this algorithm? In 2015, he was nice enough to share to a mailing list the story of how he came up with this. And I love this story because it shows that even in 1972, the key to solving tricky problems is just to get away from your desk and do something else. So Mark was walking his girlfriend's dog, and he does not like dogs, so he was just letting his mind wander while walking it. He'd been struggling with this problem of both how to store both the source code and the deltas all in the same file, and he came up with the idea of surrounding the pieces of text with these markers. And when he got back to his apartment, he started sketching out the details of how it might work. When he thought he had a workable solution, he enumerated through what he thought were all the possible cases of insertions mixed with deletions, and confirmed that each example would work. From there, it only took him a day or 2 to get it to work in Snowball 4. As the first real version control system, SCCS was obviously extremely influential, but it also had a surprisingly long lifespan. The project started in 1972, but didn't have its first public release until version 4 in 1977. It even ended up becoming part of the single Unix specification, and it's still part of the POSIX standard today, which really makes me wonder what other sort of random, irrelevant by today's standards utilities are part of POSIX. You can still find a modern fork of SCCS that was open sourced by Sun as part of Open Solaris. It's on SourceForge. That site is actually a great treasure trove of information about the history of SCCS. For example, it contains the original release notes of version 4 from 1977. It also has a link to the development mailing list, which had a grand total of 1 message in 2019 asking if they were going to add Windows 10 support. GNU also provides CSSC, which is just their version of SCCS. The intent of that is just to convert old SCCS repos over to a more modern option. Something that'll be a bit of a recurring theme today is that a lot of the people I'm going to talk about are well known for other things. In this case, it's for advanced Unix programming. Today, you can find Mark Rochkind's work on his website. I'm not completely sure what he's doing these days, but based on his website, it appears that he's busy with a wide range of hobby projects. So next up is RCS. I actually have some personal experience with this one, and this is the oldest version control system that I can say that about. Walter F. Tichy was born in 1952. He's a German computer scientist. After receiving his PhD, he served for 6 years on the faculty of Purdue University, and it was during this time that he developed RCS. So every year, the Association for Computing Machinery bestows what they call the ACM SIGSOFT Award for a publication that has demonstrated major impact. And this picture is of Tichy holding that award in 2013 for this paper, Design, Implementation, and Evaluation of a Revision Control System. So why did he create RCS, and what advantages did it have over SCCS? Let's look at his 1982 paper just a little bit to find out. So right away in the introduction, we get reminded that even in 1982, software was never done. He goes on to state that improved versions of heavily used software projects seem to arise almost spontaneously. At its core, RCS is just a refinement on SCCS. Both are still first generation tools. You check files in and out, you lock files, revision numbers are very similar. Also similar to SCCS, you could do some reasonably powerful searching to check out specific revision on criteria beyond just a specific revision number. There are differences though. The first one is branching. I mentioned that SCCS did not have any concept of it, but RCS does. So this here is an example. You can see that each branch appends another number to the version. You can also give a friendlier label to the branches as an alias. And one possible use for this is to manage releases. You could create a labeled branch for every file and then retrieve every file with that label. This wasn't something you could do with SCCS. Once again, software developers providing poor commitment messages since the dawn of version control itself. There are also some important auxiliary commands. The most interesting of them let you break locks. Even using RCS on a very small project myself in college, people forgot to release the locks on a regular basis. Interestingly, breaking the lock also sends an email to the person who previously held the lock. SCCS also supported breaking locks, but you needed special permissions to do so. And in practice, everybody ended up getting these permissions, so RCS just got rid of them. RCS departs from SCCS in the way it stores deltas. SCCS stored all the deltas interleaved with each other. RCS uses something that looks more like what you're used to. It's using reverse deltas. The newest revision is stored intact, so since that's the one you usually want to check out. If you want to go back one revision, you take the newest revision and apply reverse deltas and so on and so forth to go back through history. Then adding a new revision is just getting the latest revision, executing a diff to get the reverse delta, and then appending. The disadvantage here is that going further back in history gets more expensive, and there's additional complexity when you start doing branches where you have to start using forward deltas. Another big advantage of RCS is that it was designed to be easily used with Make. SCCS predated Make, so it was unnecessarily difficult to integrate the two. This mostly had to do with file naming conventions. There's also an identification mechanism that would use markers to insert metadata from the repository into the code on checkout. Both RCS and SCCS had this. Tichy's hope was that RCS's version would be easier to use, but I don't have any information on how that ended up working out. SCCS provided no mechanism for merges. RCS branches do support merging, but it's not clear how good that was in practice. And the implication from the reading I've done is that most teams just use locking on a single head branch instead of branching, which seems likely, but I couldn't validate that claim at all. One big thing that RCS was missing is checksumming, which is something that SCCS did have. RCS is also a bit of a case study in the evolution of open source licenses. Through version 3, which was distributed in BSD 4.3, it had this following license, which looks pretty crazy today. You needed the explicit written permission of the author to distribute RCS. And this was true until 1989, when that license was altered to this version, which is pretty similar to BSD licenses of the day. It just meant missing anything about using the author's name to endorse or promote derived products, and anything about the software being provided as is. But with RCS 4.3 in 1990, it did become a GPL project distributed by the Free Software Foundation. Today, RCS is a GNU project and easily installable as a package through your package manager of choice. The latest release was 5.9.4 back in 2015, and the project is currently maintained by TNT Nguyen. Tichy is still an active professor in Germany. So SCCS and RCS were the pillars of the first generation. The second generation is defined by centralized networking, multi-file operations, and no more file locks or editing. And for years, the pillar of the second generation was concurrent version systems, CVS. I'm going to guess at this point, there's more people in attendance who have used this system. This is actually what I have very little experience with. Most of my experience was just years ago checking projects out on SourceForge to look at them. CVS can be said to have two creators. The initial creator was Dick Groen. Groen was born in 1939 in the Netherlands, and he got his PhD in computer science in 1982, and then spent the rest of his career teaching in Amsterdam before retiring in 2004. He created the initial version of CVS in the 1984 and 85 timeframe while working on a student project where all of them had different schedules. It was initially called CMT because it allowed all of them to commit versions independently. When this project finished, he cleaned up the shell scripts and renamed it CVS. These shell scripts were just wrappers over RCS, and the initial commit of CVS under itself was on November 23rd, 1985. He posted these improved scripts to comp.sources.unix on June 23rd, 1986. You can still find these online today, and I am told that if you have RCS installed on your Unix system, they still work. But from there, Brian Berliner comes into the picture. We're going to fast forward a few years to April of 1989, and Berliner, along with others at Prisma, took those scripts and ported them to C in roughly 2 weeks. Prisma was a third-party developer working on the Sun OS kernel, and they were looking for improved tooling to merge in their changes when Sun would send them an updated version of the kernel. Using CVS, they were able to apply these changes to a new version of the kernel in just 2 days. This port turned into the official version of CVS and was released under the GPL, and CVS 1.0 became a Free Software Foundation project on November 19th, 1990. Berliner summarized his work on CVS while at Prisma in a paper that you can find at this link, but we're not going to have time to dive into that too much today. CVS was the first version control system of what became known as the second generation. All of these advantages are just defining characteristics of that generation. You could work with multiple files at once finally. Unfortunately, files are still versioned independently in CVS, but you could commit multiple at once. But the huge shortcoming of this is that CVS did not guarantee you atomic commits. It used a client-server architecture. The server contains a centralized repository, and clients talk to that repository to check code out, commit code, and other operations. The server is the centralized point of truth, and all operations must go through it. And it allowed for concurrent editing. File locks are no longer necessary. Instead, multiple developers could work on a file at once. The developer A commits first, then developer B were required to pull the new changes in first and resolve conflicts if necessary before they can commit their changes. Unfortunately, I was not able to find any hard data on CVS adoption, but there's enough indirect evidence that I'm willing to state that it was by far the dominant open source version control system of the 90s. Things get a little murkier once you start factoring in the myriad number of commercial systems. A 2007 survey by Git of its users found that CVS and SVN were by far the most common version control systems that Git users had experience with, but that's not a representative sample. An early adopter of Git is probably not representative of the average developer. CVS did become the de facto standard for open source development. There were competing paid products such as Perforce, ClearCase, and Visual SourceCase, but within the open source world, they were never as ubiquitous as CVS. Today, I would consider CVS to be a dead project. The last release was on May 8th, 2008. There have been some maintenance bug fixes since then, but nothing, no official releases. And the last check-in was on March 30th, 2011. Amusingly, there is a fork called CVS-NT that began in 1998 with the initial goal of improving Windows support. And if you want to pay for a CVS support license today, you still can. But the real future of CVS was Subversion. I'm going to guess that a large chunk of those in attendance have used Subversion, especially if you have, say, over 10 years of experience. The Subversion project was started in 2000 by CollabNet with the explicit goal of making CVS but better. CollabNet offered an enterprise suite called CollabNet Enterprise Edition, which included version control. They were using CVS for that part, but the limitations were obvious. But unfortunately, CVS had become so ubiquitous that there just wasn't a better open source option. Carl Fogel was the author of open source development with CVS. He had already been discussing a design for a new version control system with Jim Blandy. And these two had previously founded Cyclic Software in 1995 to provide CVS support contracts, so they were well aware of the strengths and weaknesses of CVS. So in February 2000, CollabNet reached out to Carl Fogel to ask about his interest in working on a version control system to replace CVS. By coincidence, Carl and Jim Blandy were already discussing such a system, so Carl immediately joined. Jim was working for Red Hat Software at the time and convinced them to essentially donate him for an indefinite period of time to work on the project. Around this time, CollabNet also hired Ben Collins Sussman. Their initial goals were simple. Jim already had a name, Subversion, and a basic design for the data store from his previous musings with Carl. They didn't want to break any new ground. They just wanted to fix CVS. They wanted to match CVS's features and development model, but avoid the big flaws. It didn't need to be a drop-in replacement, but it needed to feel very familiar to a CVS user to make the transition relatively painless. Subversion became self-hosting on August 31st, 2001 after 14 months of development. Up until this point, the code was actually managed with CVS. In November 2009, Subversion was accepted into the Apache incubator. Things moved pretty quickly from there, and it became a top-level Apache project on February 17, 2010, where it remains to this day. One major factor in Subversion becoming an Apache project was Brian Behlendorf. He was one of the co-founders of CollabNet, along with this man, Tim O'Reilly, and Bill Portelli. Behlendorf is best known for being the primary developer of the Apache web server and founded the Apache group, which became the Apache Software Foundation. The entire goal of Subversion was to create a fixed version of CVS, and they succeeded in that. The entire repo is a revision, not just individual files. Getting the repository status at a single point in time is just one version number, and they finally gave us atomic commits. Directories were versioned as well. You could run SVN commands on them. You had some support for renames and moves. You could do some operations locally finally, such as get status of changes you have made, a diff of your changes, and reverting changes. Branches and tags are just ordinary directories within the file system. You had some support for arbitrary metadata on files and directories, and you had some better support for binary files. Subversion 1.0 was released on February 23rd, 2004. It's hard to find hard adoption numbers again for Subversion, but Google Trends shows Subversion coming out ahead relatively quickly after the 1.0 release. It's definitely fallen out of favor today, but Subversion remains the most widely used centralized version control system. It's still actively developed, and version 1.13 was released in 2019. Just stepping back a bit, though, I think it's important to note that Subversion is the first of what we would consider a modern open source VCS, developed that way from the start. So SCCS was developed at Bell Labs. It was an internal project for years. RCS had some strange licensing. CVS was a bunch of scripts dumped into Usenet. Subversion was really the first version control system developed in the open, in the modern sense of what we would consider open source. Carl Fogel would go on to write Producing Open Source Software, How to Run a Successful Free Software Project. He would draw on his experience with Subversion a lot during this book. He currently is a partner at Open Tech Strategies, where he helps organizations launch and participate in open source projects. In addition, he founded questioncopyright.org, a nonprofit that advocates for copyright reform. Today, Jim Blandy works for Mozilla. He's one of the authors of Programming Rust. In addition, he's also been the maintainer for GNU Emacs, Gaio, and GDB at various points of time. And Ben Collins Sussman went on to co-found Google's engineering office in Chicago. He ported Subversion to use Google's Bigtable as storage and was instrumental in the launch of Google Code. Today, he manages teams in charge of Google's searches, overall latency, and speed. So Subversion was basically the end of the second generation, but even before its creation, the third generation was starting. The Subversion project started in 2000, but BitKeeper started before that. I have no personal experience with this tool, but as we'll see, it's an incredibly important system. It's the only commercial system we're going to cover today because the history of Git cannot be separated from BitKeeper. It's probably the most important version control system, commercial version control system ever because of that. Not widely used, but important. There isn't a lot of information available about the history of BitKeeper, though. Most of what I was able to find comes from their now open source repository, which mentions that Larry McVoy wrote a semi-distributed version control system while working at Sun, which later turned into Teamware. You can see the complete history of the project all the way back to when it became self-hosting in March of 1999. BitKeeper itself was a product of BitMover, which as far as I can tell was created solely to create BitKeeper. So on September 30th, 1998, Larry McVoy sent a message to the kernel mailing list outlining a proposal for how to solve the Linus scaling problem. At the time, Linux was experiencing growing pains. Linus was a bottleneck for getting patches merged into the kernel. The proposed solution was a distributed version control system that would allow others to test and tweak patches in a transparent manner as they made their way towards Linus through his circle of trust. This system would be developed by Larry's company, BitMover. In that message, Larry also linked to a page about SCCS, which is fascinating to me. It's a re-implementation of SCCS that adds a number of new features and served as the underpinnings of BitKeeper. So I want to step back and appreciate that for a moment. The core of the very first third generation version control system was a re-implementation of the very first generation version control system, which is just amazing to me. But in a harbinger of things to come, there's a licensing section that highlights that it will be free as a beer for free software development, but paid for commercial development. And Larry went out of his way to point out how much money he was losing by doing this project to help out Linus. BitKeeper became self-hosting in March of 1999, and the first public release was on May 4th, 2000. Back to the licensing, though, it was problematic. It tried to straddle this line between the free and commercial worlds, which is a pretty common setup today, but BitKeeper compounded it with two clauses. The first was you could not reverse engineer anything related to BitKeeper for any reason, and the second was you could not participate in the development of any competing tools. Even if you stopped using BitKeeper, you had to wait another year till you could contribute to anything else, or else you would violate the license. All that being said, though, in 2002, BitKeeper was adopted by the Linux kernel. It was a highly controversial decision. Torvalds and the other core developers accepted the free license, but others did not, and this tension would come to a head in 2005. This is when Bitmover announced that it would be revoking the license because Andrew Tridgell had started reverse engineering the wire protocol to develop a third-party BitKeeper client. McVoy said this violated the license. A lot of heated arguments ensued. Torvalds is stuck in the middle. Tridge had also been instrumental in reverse engineering SMB to create Samba, so this was very on brand for him. And he'd also co-developed rsync as part of his PhD dissertation. He argued that he had never bought or owned a BitKeeper license, so he couldn't be bound by its restrictions because he had never agreed to it. It was ethical reverse engineering, just like Samba. He also claimed that all he had done was telnet into a BitKeeper server and typed help. His goal was to provide features around metadata and comparing past revisions, features that were only available in the commercial version. But in the end, a very angry Torvalds was left to find a replacement for BitKeeper. Today, BitKeeper is just a dead project. It was open sourced in 2016 in a last gasp bid for relevance, but like anything else in the wake of Git, it didn't work out. We're going to go rapid fire here now. The stage has been set. Larry McVoy has rescinded the BitKeeper license for Linux kernel development. Torvalds is trying to figure out what to do. His disdain for CVS is legendary. He views Subversion as a bit better, but still flawed in the same fundamental ways that CVS is. He wants a distributed version control system, so he starts evaluating the existing options, which brings us to Monotone. The initial release of Monotone was in April 6, 2003. It's hard to find much information about it. The initial creator, though, was Graydon Hoare, who would later go on to create Rust. And remember that Jim Blandy, one of the creators of Subversion, is the author of Programming Rust, so we have these nice interconnections going on. The name comes from Graydon's desire to pursue the concept of what he called monotonically increasing test coverage, which basically was the idea that he wanted a repository of code where the test always had to pass for the code to get in. It was eclipsed by Git, though, and never got there. When Torvalds looked at it, he liked the usage of SHA-1 files to identify objects. This is why everything in Git gets a SHA, but there were serious performance issues. The project placed a higher emphasis on integrity, and the timing was really bad. They had just come out with the 0.17 release, which put in what they knew were some serious performance regressions to try to fix some bugs, and that happened to be when Torvalds looked at it. It probably wasn't going to be fast enough anyways, but the timing was pretty unfortunate. Today, Monotone never caught on. Its only real moment in the sun came from Torvalds mentioning that he looked at it before writing Git, and he discarded it. The last release was 1.1 in 2014. Looking through the mailing list, that just seems to have been a last gasp to pull together various patches that distros were accumulating themselves. There's been no commits since then, and the official source repository seems to be offline. The other one we're going to talk about is Darcs. David Rowdy is the creator of Darcs, and it was his little pet project, which originally stood for David's Advanced Revision Control System, but he later changed to what he felt was the less embarrassing backronym of Darcs Advanced Revision Control System. His background is a little bit different than what you would expect for someone creating a version control system. He received his PhD in physics from UC Berkeley in 2001. Then, while doing postdoctoral work, he was working on a cross-platform online bridge game called Abridge. He was using CVS on SourceForge, but he wasn't happy with it. Subversion was really new at the time, but he was interested in a distributed system, so he started looking at Arch. Arch was GNU's distributed version control system. The briefest of brief histories is that it started in 2001, petered out by 2008, but the slide is here because they win for the most adorable logo contest. In June 2002, he got involved in discussions about creating a new patch format for Arch, but it became clear that his proposal would never be incorporated. He still thought the ideas were interesting, though, and he started playing around with them, and Darcs was born. He wrote the initial version in the summer of 2002 in C++. After a lot of experimentation and dead ends, by the end of the summer, he felt he had a very solid mass of bugs to work with. So when you have a side project, you should always make it more complicated by rewriting it into language you barely know. And around that time, he had also started looking into Haskell. So guess what happened next? The first public release of Darcs was on April 3rd, 2003. Windows support was added later that summer. In April 2008, Darcs 2.0 was released. It fixed some semantics and they had some issues with exponential merges. By far the most interesting part of Darcs is its theory of patches, and Darcs are repositories of a set of patches that are not necessarily ordered with respect to other patches. It can calculate which patches are dependent upon each other and so on and so forth, so you can treat them out of order. If you're interested in learning more about patch theory, then I highly recommend checking out the official Darcs site that has a lot of good examples. The other pro or con, depending on how you look, is the CLI. It's extremely interactive. There's a lot of hand-holding that goes on, which basically makes it the anti-Git. Today, it's a very niche version control system. It's still actively developed. It's used more in the Haskell community than anything else, but even there, Git is taking over. So we finally made it. It's time to talk about Git. The early history of Git is tightly bound to the history of Linux version control. So as we already discussed, in 2002, Linus decided to adopt BitKeeper, and then this all boiled over in 2005. This left Torvalds and the wider Linux development community in a tough place. Torvalds set the following criteria for any system that would replace BitKeeper. His disdain for CVS is widely known. He had even gone so far as to say that kernel development would revert back to using no version control at all instead of using CVS. He looked at monotone and Darcs, but ended up rejecting both for performance reasons. So following the release of kernel 2.6.12-RC2, Torvalds was able to start dedicating all of his time to the first version of Git. Development was extremely rapid. On April 3rd, 2005, he started development. 3 days later, he announces the project, and the next day, Git becomes self-hosting. Interestingly, the README contains multiple meanings of the name. Linus seems to have decided that the true origin is the British slang term git, which means a silly, incompetent, stupid, annoying, or childish person. And he claims that he's now been arrogant enough to name 2 projects after himself. On April 18th, there's the first merge of multiple branches. And on April 29th, the performance goals are met. They record 6.7 patches per second. They then go on to manage the 2.6.12 kernel release on June 16th, 2005. At this point, Torvalds turned over maintenance to Junio Hamano. On July 26, 2005, Hamano up to that point had been a major contributor. 1.0 was released in December 21st, 2005, and Hamano remains the project maintainer to this day. In the early days, Git was notorious for being difficult to use. Linus had developed a system designed specifically for his workflow around merging patches into the Linux kernel, and there was little to no separation between the internals and the porcelain, which is the commands exposed to the users. It took quite a few years to make the project more usable, and in a 2007 talk at Google, Torvalds mentioned that he thought that Git at that point was mostly usable for other projects. So Git had a huge advantage compared to any other version control system in history. It had this highly visible conflict over BitKeeper on the most highly visible open source project in the world, with the most famous open source developer in the world as a central figure. And these things combined just gave it enormous visibility. But then Git actually was able to capitalize on that visibility by rapidly creating an initial version and using it to manage a release of the Linux kernel. We can see on this Google Trends graph, the buzz around Git surpassed Subversion right around 2011. This graph shows Git adoption versus Subversion from 2009 to 2014 in the Eclipse Community Survey. You can see that in 2014, it surpassed Subversion. By 2018, the Stack Overflow Community Survey showed that almost 90% of their 74,000 respondents preferred to use Git. The results were so lopsided that in 2019, they just dropped the question completely. We're not going to dive into any details of Git internals, but I think it's just important to highlight again how unique Git is compared to what came before it and why. So there are 3 primary design constraints and influences that had a large effect on the initial design. Torvalds' experience maintaining a large distributed development project, his intimate knowledge of file system performance, he knew file systems, so that is why Git does not use a database, and the urgent need to have a working project in short order. Torvalds gave himself a 2-week deadline for this initial version. This here is a post from Torvalds himself in October 2006 to the Git mailing list, explaining how BitKeeper influenced him to not make a BitKeeper clone. He respected McVoy's work too much to do that. I'd highly recommend checking out this entire post if you can, and it's really great that the entire history of Git is available in both Git and mailing list discussions. It's really unique and in stark contrast to how difficult it was to find information about other version control systems. The biggest contribution from monotone is just the idea that every object has a hash. Torvalds was already planning on using hashes for the history, but Monotone took it further, and he really liked the idea. Git today, it won. That's it. There's not much else to it. I don't have time to dive into it right now, but Git wasn't the only version control system to emerge from the ashes of the BitKeeper fallout. There was also Mercurial. The extremely, extremely condensed version of that was announced 2 weeks after Git, and that was 2 weeks too late. So that was a lot. In 1972, we got the first version control system in SCCS. In 1985, we got the first iteration of CVS, kicking off the second generation of version control systems. In 2005, we got Git, which kicked the third generation into high gear, bringing distributed version control systems more mainstream. But 2005 was a long time ago. Is there anything else on the horizon? In just about every other area of developer tooling, there are new options created every year. But sadly, after an explosion of distributed systems in the mid-2000s, there really isn't much to talk about. But why? It's because of this guy. This is the primary reason that there's no viable replacement for Git on the horizon. Previous generations of version control didn't have to deal with such a strong network effect when replacing the old. Everything works with GitHub. All new open source projects are hosted there by default. There's an entire DevOps industry around it. Realistically, any new version control system would have to be adopted by GitHub to gain significant traction. We don't have adoption numbers for the entire history of version control, but I feel confident in saying that there's no other version control system has ever had such numbers. The market was fragmented across many different open source and commercial options before, and that's just not true now. And with that, I'd like to thank you all for sticking around to the end of the day. The slides are, of course, available on GitHub. Where else would they go? And one more plug for Hacktoberfest. If you're interested, follow InfernoRed Tech on Twitter. I'd like to thank Scott for moderating and all the other organizers as well, and can open it up for questions now.
Great, thank you, Brian. If you have any questions, please feel free to publish those into the live Q&A. I know that during the track that Mark Oliver, I think he was one of the speakers today, said, SCCS, I remember that, I'm old. So that is, you got one comment. Are there any questions? Anything at all? There's 10 attendees live in the live right now. So if there are any questions, we know we're a little bit delayed in the live versus the attendee feed, so we can wait a few moments here to see if they pop up. Anything at all? Any questions? Brian, I've seen you do this talk before, and I know that was the rapid fire version in a condensed 48 or 47 minutes. We'll make this talk available online as well eventually as we cut up all of the talks in the hours of today. But this is also available if you are interested on Pluralsight as part of the CodeMash free sessions. I believe they're still free.
They should be.
Should be still free. So if you just search up Brian Meeker, CodeMash, you'll find the slides. And all right, so it doesn't look like we're going to get any questions, but thank you, Brian, for taking the time to give the presentation today. And thank you to everybody who was in earlier sessions for sticking around all day for our first virtual code camp. Hopefully, sometime in the near future, we'll be able to be live again in person. But until then, thank you all and have a great weekend.
Thanks, everybody.